Hello everyone. So today we are going to talk about this question, coin change. So let us read the description what it is saying. So coin change. So you are given a coin of different denominations. Okay, and a total amount of money amount. Write a function to compute the fewest number of coin that you need to make up that amount. If that amount of the money cannot be made by the combination of the coins, return minus one. Okay, you may assume that you have an infinite number of each kind of coins. Okay, so let us see the example for a better understanding of the statement. So, for example, the coins are denominations are 1, 2, and 5, and we need to make the amount of 11. Okay, so we need to make 11, and we need to use the fewest coin. So, one way can be you can use 11 one coins, so which can add up to 11. So, that is the one, but that takes more coin. But if you take two 5 coins, okay, 5 plus 5, and you again take one coin which adds up to 11. So this is the fewest coin. The solution is this one. So the output is 3 for this case. Now you can see the coin are 2, that is denomination is 2, only we have a coin of 2 and you need to make amount of 3, which is not possible. So in that case we are returning a minus 1 here. Okay, now your coin is 1 only and you need to make amount 0. So what will be the output? The output will be 0, because if you want to make amount 0, then just don't use any coins. So the output for this is 0. Now if you have coin 1 and you want to make amount 1, so you have output as 1. Okay, because you can use that coin itself, that gives the output as 1. Now let us see the fifth example. Let me scroll down. So here in this example you can see the coin is 1. Okay, the denomination is 1 and the amount is 2. So how many coins you can do? Minimum you need 2 coins, 1 plus 1, which adds up to 2. So that will be your solution here. So let us see the constraints what they given. The coin's length can be up to 1 from 1 to 12. Okay, both inclusive. And then the coin I can be up to 2 to the power 31 minus 1. Okay, and from starting from 1, and the amount can be up to 10 to the power 4 from 0. So these are the constraints. Now your task is to pause the video and try to guess the solution for this code. So this is basically a DP question. So try to implement this by using a DP and try to find some patterns in the coin. Okay, so you can pause the video and try to write the code by yourself. So let us discuss the code. So here what we are doing, first of all we are making a vector of double type, and we are calling that vector as dp. Okay, so let us make the dp here, and what we are doing, we are up to the amount, we are just making that array, and we are filling that with the value int max. Okay, so in this you can see we are going to have up to only 12 values from 0. Basically indexing will start from 0, but the spaces will be 12. So basically there will be 12 size. So 1 2 3 4 5 6 7 8 9 10 11 12. Okay, like this it will happen, and all the values will be your int max. Okay, so all of them will be int max. I'm not writing im. Okay, int max, all will be int max initially. Okay, so this is our dp, and now you can see what we are doing. We are first initially we are storing dp0 as 0. Okay, so for this case we are just writing 0 here, and we'll start our iteration from I equal to 1. Okay, so for I equal to 1 we'll go up to amount. Okay, less than equal to amount. So this will be, suppose this is index 0, this is 1, this is 2, this is 3 4 5 6 7 8 9 10 11. Okay, for all this value we need to fill the values, something we need to fill in that. Okay, so what we are going to do, we are going to start our iteration from I equal to 1. So we'll start our iteration from I equal to 1, and we'll go up to amount, which means we'll cover this all dp. Okay, now for each I equal to 1, for example for this we are going to take all the values from this coin. So this is basically the coins, the coin vector which they are given. Okay, and we are using a reference, so we are just referring to the original vector. Okay, so we are going to see now in this 1 to 5 coins we are going to select each and every, and we are going to find the minimum. So if the coin, suppose this is the coin, is less than I, what is I is this value which is index value. So here is 1. So for this case you can see the coin, this is coin referring to, first it is referring to the 1, then it will refer to 2, then it will refer to 5. Okay, now you can see this coin is less than equal to I, because I is 1 in this case. Okay, we are talking about I equal to 1. So suppose here I equal to 1, and we are going to refer 1, 2 and 5. We are going to check. Now you can see this coin, which is this value is less than equal to I. Basically it is equal to I. So we are going to store this dpi, dp of basically 1. It becomes minimum of dp of I, or dp of I minus coin plus 1. Okay, so so it will be like minimum of dp of I. Now dp of I is initially int max, so it will be minimum of int max comma dp of I minus coin. So coin will be starting will be 1, so 1 minus 1 which gives 0. So dp of 0 is nothing but 0, and we are going to add 1. Okay, so we are adding 1 here, so it will be minimum of both int max or 1, so it will be 1. So in dp of 1 we are going to store the value as 1. Okay, so basically it means that the amount 1 can be made with the 1 coin, that is denomination 1. Okay, that is the minimum value you can get. So now let us see the, for example, for 2 what will happen for basically it will run for other values also, but you can see the other values will be greater than this one, so it will not be checked for this, for those. Now when I equal to 2, we are going to again see with the 1 value. Now it is less than, so we are going to check. We are going to take dp of 2 will be nothing but minimum of dp of I. Okay, dp of I is int max again for that value, and dp of I minus coin, I minus coin is 1, so 1 minus 1 will be a dp of 1. Okay, so it will be 2 minus coin is 1, so it will be dp of 1 plus 1. So dp of 1 is already we have got 1, and 1 plus 1 give us 2. So this is basically 2, dp of 2 will be 2. Basically that is the minimum denomination you can get when the values are 1 and 2. Basically the values are 1 and 1, so you can use 2 of the coins of denomination 1 for getting this value 2. Now when you are including this 2, when you are going to talk about this 2, so in that case what will happen, we are going to see. So for when you see the dp of 2, now when we are talking about the second case in which it is checked for this value 1, 2, basically it will check for 3 values, but now we are talking about 2. Okay, so for this we are going to see this coin is less than equal to 2. Okay, less than equal to 2, so it will be checked the minimum of dp of 1. It will be, now it will be checked as minimum of 2 comma dp of I minus coin. So I minus coin is nothing but 2 minus 2, basically is 0, and then plus 1 gives you 1, so minimum of 2 comma 1 which gives us 1. Okay, now when you have denomination 2, you can get the minimum value as 1. Okay, so in that case we are storing 1 here. Now it will be like this, 0, then 1, then again it will be 1, because you can use 2 denomination. Like this it will be storing all the values, and at the end what we are going to see, the value which will be stored in the 11th, you can see, which will be nothing but the value 3 in this case. Okay, how 3? Because we will be taking 2 5s and then 1. So basically in the 11 it will be storing value 3 here. Okay, so at the end it will be storing 3 here up to 11 places. Now we are going to just return if dp dot back is equal to int max, then in that case we are returning -1. Otherwise whatever the value we are getting at the back, we are just returning that. So basically that is what the solution is. Okay, so I hope you got the basic idea of this coin change problem. So we'll meet in the next video with another such problems.